Hi everyone, I'm Brian Willie, and with Carissa Vincentio, Genta Indra Winata, and Samachaya Wijaya, we are presenting IndoNLU research paper. This is the benchmark and resources for evaluating Indonesian natural language understanding task. We are sponsored by Gojek, Prosa, HKUST, Universitas Indonesia, Institut Teknologi Bandung, and UMN. This sponsorship is actually coming from both the industrial world and the academic world. So this is the first ever fast resource for training, evaluating, and benchmarking on Indonesian natural language understanding task. So Indonesia is actually the fourth largest internet users, just following China, India, United States. But we are still facing the common NLP research problem that is no standard or almost impossible to reproduce results from existing work, and datasets are either not accessible or scattered. So here we are to introduce the IndoNLU benchmark consisting of 12 downstream tasks on natural language understanding, and also the Indo4B datasets. This is our datasets of around 4 billion words, and this is around 250 million sentences that cover both formal and colloquial Indonesian sentences. And the IndoBird model, we are also introducing a conceptualized model developed following BERT and Albert architecture. So this is the 12th downstream task that constructs the IndoNLU benchmark. So the task consists of classification task and sequence labeling task, both in single sentence and sentence pair. And the domains are so various. We have tweets, general, automobile, hotel, wiki, news, banking, and the styles are colloquial and formal. So I'm going to explain one by one. So in classification task, single sentence, we have emotion classification. This is a 4,000 Indonesian tweets labeled as anger, fear, love, happiness, and sadness on sentiment analysis. We have SMSA. This is 12,700 reviews labeled as positive, negatives, or neutral. We have also the aspect-based sentiment analysis on car reviews and hotel reviews, KESA and HOASA, with 6 aspects of core quality, with labeled positive, negative, and neutral. And the HOASA is a 10 aspects of hotel quality labeled as positive, negative, neutral, and positive, negative. On the classification task, the sentence pair task, we have the wiki revision edits textual entailment. This is a 450 sentence pairs labeled as entail or not entail. We are taking this from Wikipedia revision history. And from sequence labeling task, on single sentence, we have this both post tagging task. BayPos have 10,000 sentences with 23 post tags, and PostP have 8,000 sentences with 26 post tags, both following the IB chunking format. And for sequence labeling single sentence, we have this term A. This is a span extraction. Have two span tasks, aspect and sentiment, with 5,000 hotel reviews. And this key phrase extraction caps, we have 1,000 tweets with no specific key phrase tag. And these both are still following the IB chunking format. Also, we have both name entity recognition task, NERGRID, and NERPI. This is 2,000 sentences, consists of 3 NE tasks, person, place, organization. And this is NERPI consists of 8,500 sentences with 5 name entity tags. And both are following the IB chunking format. And the last one, from sequence labeling sentence pair, we have the question answering factoid dataset, FAQA. This is a pair sentence of question and passage. This consists of 3,000 sentence pair and 6 question types: state, location, name, organization, person, and quantitative. And this is still following the IB chunking format. So next, this is the reference. So this is the reference for all the tasks, the data set that we use in the 12 downstream task. So next, we are going to introduce the Indo4B dataset. Indo4B dataset consists of 23 gigabytes and more of Indonesian data with 3.5 billion words from 15 sources, both colloquial and formal listed here. So we have mixed style, colloquial, formal. This is the sources. Some is from Oscar, from Open Subtitle, also from Common Crawl, and Wikipedia, Twitter, and stuffs you can see here. And this is the sentences around 3.5 billions and with around 275 million sentences. And next, we are going to introduce the pre-trained models. So we have fast text models, fast text, CCID trained on CCID datasets, same 15.1 million parameters. Then this is the fast text trained from Indo4B datasets that we just introduced to you just now. And we also have the IndoBird models. We have IndoBird and IndoBird Lite. This is following the Bird and Albert architecture with the respective parameters on base and large configurations. Okay, so this is the pre-training time informations on the IndoBird models that we train. We train the IndoBird models on two phases. On the first phase, we only use maximum sequence length of 128, and on second phase, we use maximum sequence length of 512. This is actually following Google's advice on training BERT using long sequence length. And this is the information on batch size, learning rate, steps, and durations on our models. And we are using the TPU v3.8 for pre-training, and we are using V100 NVIDIA V132 gigabytes for fine-tuning. Okay, on our experiments and analysis, we will compare some baselines to the IndoBird models. So we have here the transformers from scratch. We also have a word-to-vec model. This is the fast text trained on CCID dataset, and also the multilingual models like MBird, XLM, and XLM Roberta. So here's the result of the baseline model with best performing configurations on the IndoNLU benchmark. Here we can see the bold ones are actually the best results among all in the column. So here, the bold one is actually the best performing models in the downstream task dataset EMOD. And here, the bold one is the best performing result on average on the classification task. And this one is the best performing result on average on the sequence labeling task. And we can see here that XLMR large, IndoBird base, and IndoBird large achieved the top 3 base performance result on the classification task. But on this one, the sequence labeling task, the XLMR large, IndoBird large, and XLMR base achieved the top 3 base performance result on the sequence labeling task. And these experimental results suggest that larger models have a performance advantage over smaller models. And we can also see that all pre-trained model outperform the scratch model, which shows the effectiveness of model pre-training. And another interesting observation is that all contextualized pre-trained models outperform the word embedding-based models by significant margins. This shows the superiority of the contextualized embedding approach over the word embeddings approach. And actually, this is the multilingual models sections, and this is the monolingual model sections. And based on here, we can see that on classification tasks, we can see that monolingual models outperform contextualized multilingual models by large margin, but on the sequence labeling task, we can see that multilingual models tend to perform better compared to the monolingual models, and actually even perform much better in the NERD grid and FAQ downstream task. As shown before in the downstream task examples, we can see here that both NERGRID and FAQ tasks contain many entity names which comes from other language, especially English. These facts suggest that monolingual models capture the semantic meaning of a word better than multilingual models, but multilingual models identify foreign terms better than monolingual models. And here we can also see that IndoBird models outperform the multilingual models on 8 out of 12 tasks. In general, the IndoBird models achieve the highest average score on classification tasks. We can actually see that monolingual model learns better in sentiment level semantics on both colloquial and formal language styles than multilingual models. Even though the IndoBird model size is 40% and or maybe 60% smaller. And on the sequence labeling task, the IndoBird model cannot perform as well as the multilingual models, XLMR, in 3 sequence labeling tasks. Here, the POSP, NERGRID, and FAQ. Meanwhile, the IndoBird Lite models achieve a decent performance on both classification and sequence labeling tasks with the advantage of compact size. And we can see here the Indo-BERT light models achieve a decent performance on both classification and sequence labeling tasks with the advantage of the compact size. Interestingly, the Indo-BERT light large, this one model performance is on par with that of XLMR base while having a 16 times fewer parameters. We also observed that increasing the maximum sequence length to 512 in phase 2 improves the performance on the sequence labeling task. Moreover, training the model with longer input sequences enables it to learn temporal information from a given text input. So comparing the performance and space, we can see here, this is the classification task performance versus space trade-off, and this is the sequence labeling task performance versus space trade-off. And from here, we can see two large clusters on bottom left, the Scratch and the fast text models appear, and they have the lowest F1 score and the least floating points in the inference time. But on the top right, we can see that the pre-trained models achieve decent performance, but in the inference time, they incur a high computation cost. Interestingly, in the top left region, we can see that Indo-BERT light models which achieve similar performance to the Indo-BERT models, but actually with many fewer parameters and slightly lower computational cost. And from this one, we can actually see the effectiveness of Indo4B dataset by comparing the FastText CCID model and FastText Indo4B model on classification tasks and sequence labeling tasks. From here, we can see that the FastText model trained on the Indo4B datasets consistently outperform FastText model trained on the CCID dataset in both classification and sequence labeling tasks and in all model settings. This suggests that relatively smaller datasets in the 4B, only around 23 gigabytes, can significantly outperform its larger counterpart. The CCID is around 180 gigabytes. And we conclude that even though our Indo 4B dataset is smaller, it covers more variety of the Indonesian language and has better text quality compared to the CCID dataset. Okay, so that's that. Thank you for listening. And for more information, you can visit our homepage here at indobenchmark.com. We also have a GitHub, IndoBenchmark. And on our homepage, you can see we have this landing page. We have home, we have leaderboard, and you can actually submit there. So we are happy to introduce that our models are hosted in Hugging Face. So you can download easily our models using this Hugging Face library. This is the name of the models with respective phases, phase 1, phase 2 on IndoBERT's models. Yeah, we have already quite a download from the last 30 days. And this is our GitHub. You can visit our GitHub, IndoBenchmark/IndoNLU. Don't forget to star. And this is the leaderboard. You can participate by clicking the submit button that will lead you into the Coda Lab. And you can submit your Coda Lab, and our leaderboard then will be updated by the Coda Lab results. Thank you, everyone.